don't know if I need this. I think I'll just stand in front of the mics here. So yeah, probably a lot of you at least know who I am. So I'm Alan Akash. I work at the University of Barcelona, and I kind of have an affiliation with CECAM, whose headquarters are in Switzerland as well. And that's a good connection because I'm here to talk about the MultiXscale EuroHPC Center of Excellence. So what is it? It's a collaboration between scientific partners that come from the CECAM network. So as I said, that the headquarters of that network is in Switzerland, but it's been around a long time, like 50-something years now, and it has nodes across Europe, so it has lots of scientific partners in different countries. And so they're the scientific drivers for MultiXscale, so they're delivering 3 pilot use cases. And then we have the technical partners that kind of come from people who are connected to, say, the EASY project or initiative. So we provide tooling to allow them to develop and deliver their application software and make that available on systems where they want to use it, and also on EuroHPC systems and beyond as well. So what do we actually try to do? So we've got 3 targets in mind. We want to increase the productivity of the scientists who actually develop or use open source codes. So we want to make it, we want them to spend less time dealing with technical details, right? Reducing the technical burden of interacting and using HPC systems. We want to increase the performance of the code on EuroHPC hardware. So that means like supporting that hardware in the first place and making it easier for people to develop code that can leverage that hardware well. We want to increase the portability of the codes that they do use and the workflows to make sure that, especially the workflows, to make sure that they can transfer those workflows, the way they do things, from different systems. So whether that's their own laptop or servers or in cloud environments, to make sure that that also works in HPC systems for them, without a lot of effort. The focus is, in our case, is multi-scale modeling, and also then leveraging the opportunities that EuroHPC provides to that entire community as well. And then we want to advance it. So that's the adoption as well within the community. So not everybody are HPC, not everyone within that community and within the CECAM network are HPC users, but they do simulation all the time, right? The network is designed around the fact that they use computational simulation, and so we want to advance that community a little bit, expose them more to large scale resources, and open that door to them to leverage those kinds of resources. So there are 3 pilot cases that we're interested in. One of those is batteries for sustainable energy, right? So a lot of people are working on batteries these days. Specifically in our case, we're talking about supercapacitors. So supercapacitors, I'm not an expert in this field, but you can imagine them as like lithium-ion batteries are like long distance runners, and supercapacitors are like sprinters. Okay, so they can absorb a lot of energy very quickly, and then they can deliver that energy again very quickly. So the idea is, because they have superior power density and everything, they can absorb that energy. So if we think of something like a train coming to a stop, that's a lot of weight, right? So coming to a stop in a short distance, that's a lot of energy, right? Supercapacitors have the capacity to store that energy, and then when the train starts again, and they can release the energy. So this technology is already used in supercars. So you see this technology already in supercars, and ultimately you would like to see it in more places, but that depends on the cost, right? It's trying to get the cost of these things down, their efficiency up. And so actually predicting the properties of materials, that's complicated, and you need multi-scale to be able to do that. The second one I wanted to mention was biomedical applications, so ultrasound in particular. You could kind of think of what they're trying to do as a digital twin for the ultrasound process. And like me, I don't know too much about ultrasound. I've had it done to me a couple of times. I've had it done when I was having a child, right? So you see an image of a baby, so you know it can be used for that, but it can be used for other things as well. So it can be used for non-invasive treatment, and if you can do it well, it can be used for things like drug delivery as well. So, right, it's a very interesting technology. The way it's done right now is actually quite crude, and so being able to simulate that process allows a lot of possibility in being able to do a better job and use ultrasound for more applications. The last one is helicopters for civil applications. So I imagine you've all had problems landing your helicopter on the back of your yacht. So and this is a big issue, right? No, I mean generally speaking. So in general, helicopters are complex bodies, right? So they're like, there's a lot of things happening at once, right? You've got these rotors that are spinning around, like things are moving very quickly. They're moving through air, they're deforming. There's lots of things happening at once, so it's quite difficult to simulate them. And then if you are doing things like trying to land a helicopter on the back of a ship that also has a shape and affects the airflow and everything, this is very complicated to do. And so certification of helicopters is a time-consuming process. And so part of what we're trying to do is to make that simulation easier to do, to make it more scalable. So you have to use like commercial tools, and they don't scale very well. So it's difficult to do these things quickly. And so certification is kind of what we're targeting here, to be able to simulate things better, faster, and at a larger scale, so that people can move a bit quicker with helicopter design. And then in general, these three things together, what they are is like a motivation that requires some technical innovations on our part. So we were able to come up with a concept that allows like the ideas that we have that you've seen already in the EC case, and to be able to apply them for a particular community. So each pilot is dealing with phenomena that happens at multiple different levels, so multiple scales. So you're interested in the big picture and also in the fine details as well. You need, excuse me, you need to be able to map between the two of those. So when you need your binoculars and when you need to be able to look at something close up, you need to be able to simulate at that level then, but then you also want the big picture. You can't have the fine detail at the big picture scale, and so you need to be able to find a way to map between the two. And that's what's common between all those three cases, is that's required in both of those. So the other thing is the resources, right? So the reality is that right now, these days, for scientists in Europe, you have access to large scale resources, and they are available to you for free. That's in the EuroHPC environment. But typically you also have access to national level resources, or maybe even at the institutional level as well. Having access to these kinds of resources, it's not enough for scientists. They want their entire scientific workflow, so not necessarily just a single package. They have an entire, especially when it comes to multi-scale, you're talking about coupling different applications together. Because they're interested in different scales, they have workflows to do this, so they don't just want one package, they may want multiple packages. And also that what we've seen in the multi-scale space is that they may want to swap these out, right, for various reasons at some point in time, right? Because if something comes along that does a particular scale better, they may want to switch that, or there may be particular problems, like one solution works for the case of ultrasound, but maybe something similar requires a different solution, which may mean different software packages as well. So access to resources is not enough. We want scientific workflows, and then we want to make it easy for scientists to be able to use these resources and to be able to move between them, right? So to fluidly move between the different resources that they have access to, depending on how successful they are in getting access to those resources. So this is where Easy comes in. So it's the shared software stack. So we have the applications right now, say, that we're interested in. A couple of those are Walberla, Lattice Boltzmann simulation package, Espresso as well. LAMPS is one that we use, so people are developing plugins for LAMPS. But there are other applications as well. The concept then is that they all go inside Easy, and then through Easy they will be available on all the EuroHPC systems. Now, in general, to go beyond, like, what else are we trying to do in the context of multi-scale specifically for ourselves? So Lara already mentioned this idea of Easy Extend, so to be able to build on top, to use Easy as a base layer and build additional things on top. So yeah, here Easy is the base, and then we install other things on top. The Easy Extend module looks a little bit complicated, but basically all it's doing is setting a set of environment variables that configures EasyBuild. And we use it ourselves to build the software that we deliver. So you're getting the same experience that we get, right? So you're configured exactly the same way that we are when you build on top. The difference is, like in the slide here where I show that it's being delivered to a home directory, you have different possibilities in where you do the installation. So for ourselves, there's an environment variable that says we're targeting the main repository, right, CVMFS. But you can extend Easy at the site level. So for the entire site, make it visible across your site. But you can also do that at a project level and a user level as well, right? So there are different ways of extending. So you can do that privately for yourself or for a group that you're involved in because you're working together on a particular software project. You can shadow installations that are inside Easy as well, or you can build your own things. And Lara already mentioned, in fact, we share more than just the software stack. We also share slide decks. So these are the same slides that you've just seen, but basically we're working as well towards continuous integration. So we've already created helper things to help you in like a GitHub or a GitLab environment, so you can have that Easy stack in seconds. So in less than a minute, you can have all of the software that's available in Easy inside a CI platform. And of course, in the case of GitHub right now, if you're an open source project, that CI is for free. In GitLab, there are some free stuff available, but it's a little bit different than environment, right? So you will need to come with your own resources in some cases. But it does mean, because of we use the GitLab component, they're called, because of that GitLab component, that does mean that you can have that on a private instance as well, right? So you can leverage these things on your private GitLab instance as well. So Easy can provide things like the compiler to test your software, and the dependencies that you might have there. It can provide additional tooling that you might need to use for your package, and then to get access to Easy, if you use the GitHub action or the GitLab component, you don't need to do anything else. It's just there, and you just say module load whatever I'm interested in, and away you go. So as part of the CI process, it's reasonably straightforward to integrate that, and I'll give you an example now. And so it also, as well, because you have this environment that you can access in different places, it also significantly facilitates running those CI tests in different environments. So whether that's on your laptop as well, so being able to reproduce those tests locally and see if they also run for you, that's also more straightforward. This is also was shown already. It's an example of what that looks like. I think it's hard to see it, but I think the most important thing there is how long it takes to get it set up. So on this slide, it's 52 seconds. It's a bit architecture dependent, but it doesn't really go above about a minute and 10 seconds, right? So it's a minute and 10 seconds to get access to all of the software that's inside Easy in that environment. Okay, so I'm nearly done. And so this was an example also already shown about how you could do that. I mean, the most important thing here is at the end is that you say you just load module load TensorFlow. You have access to TensorFlow. TensorFlow is a bit intensive. It takes a little bit longer to load, but we're still talking on the order of minutes. And what we can do inside Easy is make sure that because you're caching these things, you're pulling them through HTTP traffic. We can make sure that it works well in those environments, because we can put mirrors close to where these actions are being run, right? So this can run really, really fast, and that's something that we can help to do, and we get support to do that as well, right? So we get credits from AWS, we get credits from Azure as well. So we don't pay to do this, but we can provide a better service that way. So putting these things together a little bit, and some rather recent developments in EasyBuild as well. You can use like an EasyBuild recipe, like a development recipe, which uses a feature that was recently introduced into EasyBuild called software commit. So you can just take a commit hash from your application, assuming that it's delivered via Git, and then you can just change your sources to be Git repository sources. You can use the software commit then, so you can give the commit that you want to build on the command line to EasyBuild, and then you can use Easy then to test and build your stuff in a CI environment. So the simplest case is where all of these dependencies are already existing in Easy and you just want your own application. Pedro will go into more complicated cases in a minute, right? So I'm just going to show you the easiest case. In GitHub these days, I don't know if you know, but you can test on ARM and x86 these days. So you can do your ARM testing in GitHub for free as well. The future work that we're interested in is I don't know if you use it, but there's something called the build-env module in EasyBuild as well, where you get a certain set of environment variables that facilitate like building software. So you get common things that you would use that are present when inside EasyBuild itself when it's building the software. What we want to do is be able to export the RPath wrappers that are used inside Easy in the build-env environment, and that will allow you to directly use the compiler wrappers that we use, which means all the RPath injection and things like that will happen by default. So you, as a user, you won't have to know some of these like technical details, hopefully. And then the final slide is just the partners who are involved. But what I wanted to show you was an example of this. If I have a minute, do I still have a minute? 2 minutes? Oh, that's great. So what I did was I cloned a tool, BCF tools, because I knew it didn't have too many dependencies. And I played around with it to make it work in this environment. In this EasyBuild directory, I created a new development easy config. So there was already an easy config for BCF tools. What I basically did was I just changed the sources to use this new software commit thing, so that it's pulling the sources that it's actually going to pull down is dependent on a parameter that you give in the command line. as a result, I had to change a couple of other things because it uses auto tools, so I needed to create the headers that it requires an autoconf. This is all documented in their repository, but I had to do it because with the release you don't need to do these things, but in this case I did. So I had to add a new build dependency and a new pre-config ops line. That's it. That's my development easy config. And then the other thing is I needed to set up the CI. So in this case I'm working on GitHub. So this is my. So this is what that looks like. I allow myself to trigger it because I'm going to trigger it now. So it's a workflow dispatch. I don't know if you've seen GitHub Actions before, but basically on any push or pull request, I'm going to run this. It runs on a matrix of different operating systems. That's because I want two hardwares. I want ARM and x86. So I'm running on both of those the corresponding images, which will give me access to those architectures. The last two lines are probably the interesting ones, where I'm just I'm checking out the repository. I'm using the easy GitHub action. I'm loading easy extend, and then I'm just running the EB command with the software commit. And then I use GitHub SHA as what I get in CI, so I know I'm running for the current commit that's being run in the pull request or been pushed to the repository. And that's it. And we can run that, and we can even run it now. And I'll take questions while I'm doing that. So here I can go to the action, and because it has this workflow dispatch, be able to trigger this. Screen is too small. Can I see it? Where's the? Help now. This. Where? I can't trigger it. I can trigger. I go over there and trigger it. I have no mic. I can't. Well, anyway, I can show you the one I ran last night, right? Okay. Oh yeah. I was kind of hoping to do it. I'll do it live. Take a question, just
yeah, just a quick question, Alan. For BCF tools, I notice you have no checksums. So do you have an idea how to deal with those?
I mean, in this case, it's not relevant because I'm commit by commit basis. This is development easy config, right? So, okay. So I don't know if I can. It's hard, no? I don't. I did create the development so that the checksum is reproducible. It's this new feature, right, in EasyBuild 5. So I did do it in such a way that it will be a reproducible checksum.
But in CI, there's no point. You're getting a commit, and you have to trust the commit, whatever's in the commit. So there, it's not really relevant.
So I have a question about easy extend. How does it work together with existing easy configs? Because I noticed that a lot of things that are modules in vanilla EasyBuild are in the compatibility layer in easy. For instance, like incurses and so on. So how does it work if an easy config then specifies incurses as a dependency? So obviously if you build on top of easy, you want to use the one in the compatibility layer.
There's an easy answer there. We configure EasyBuild to filter out those dependencies. So there's an option, configuration option, filter depths. Incurses is in there, and whenever EasyBuild sees incurses as a dependency, it just throws it away. And then you're responsible for making sure it's there in some other way. Yeah, that may be interesting. It's a generic feature in EasyBuild. It has nothing to do with easy per se.
Our filter depth is like this.
Yeah, because in Canada they have a way fatter compatibility layer, right? So you're kicking out a lot more stuff. Yeah. And sometimes the easy blocks have to be aware of that. But yeah.
So you could look at the module to see all the different settings on the side, or load it and then just check the EasyBuild configuration, and you'll see all the environment variables that have been set to do this type of thing. But yeah, the environment you get is exactly the one that we use ourselves to install things, right?
One more, yeah. While Pedro gets set up, we can take one more question.
Hi. So you put BCF tools, like you compiled them on top of Easy, right? What happens if there's already a BCF tool which exists in Easy with the same version but maybe with different config ops? And
Do you have more, or
No,
I can answer that, right? So in this case, that would never happen because I'm doing on a commit based. Like the final module has the commit in the name, right? So it would never happen that I would shadow. But if you want to shadow, you just add an option, right? So minus rebuild will rebuild something that already exists as a module, and then that will be your private module. That will be preferred, right? Because it's just order of precedence. It's whatever appears at the top level is the one that you will get. Yeah.
And in this setup, you're just building something temporarily. You're just building to see if it works and if it maybe passes your test suite. When that workflow completes, everything is gone again. So you don't intend to keep it. Yeah. Okay, can you set up the stream?
Oh, yeah.